A lot can happen in a second. You could meet a stranger, snap your fingers, fall in love, fall asleep, sneeze. But what is a second, really, and is it as precise as we think it is? Right now, the most precise clocks used to tell global time have an error of about 1 second every 300 million years, so a clock that started ticking in the time of the dinosaurs wouldn't be off by even a second today. But scientists think we can do better. So, they are looking to lutetium, a neglected rare earth element that has been gathering dust at the bottom of the periodic table, according to a new study published April 25 in the journal Nature Communications. In the olden days, a second was defined as a fraction, 1/86,400, of the average solar day, the 24-hour rotation of the Earth around its axis. But the rotation of the Earth can vary slightly, so scientists decided to stop scanning the heavens to calibrate our clocks and scale things way down, to the level of atoms, the invisible building blocks of matter. In 1967, the International Committee for Weights and Measures defined the second as the amount of time it takes for a cesium atom to absorb enough energy to be excited, that is, for its electrons to jump from one energy state to the next. For this to happen, the atom must be pulsed with exactly 9,192,631,770 cycles of microwave radiation. Though that number might seem random, it comes from measuring the frequency of microwaves needed to excite the cesium atoms in the average of the earlier definition of 1 second. These measurements were taken over a span of nearly 3 years, Scientific American reported. Currently, hundreds of cesium atomic clocks are responsible for keeping global time and controlling GPS navigation. But in the past decade, another generation of atomic clocks has emerged, called optical clocks, and they are 100 times more precise than the cesium variety. The new clocks work in the exact same way as the cesium ones, except they use atoms such as aluminum or ytterbium that get excited by higher frequencies of visible light, hence the name optical, rather than the slower microwaves. This higher frequency adds more data points to the definition of a second, making the measurement more precise. To understand this, imagine the different types of clocks as a pair of rulers, said Murray Barrett, an associate physics professor at the National University of Singapore and the lead author of the new study. If the older, cesium ruler measures a line that's 20 centimeters, 7.9 inches, long, the more precise, optical ruler can measure the line also as, for example, 200 millimeters. While optical clocks are very precise, getting them to run for a very long period of time and to remain stable in their environments can be problematic, Barrett said. A room's temperature can change the electromagnetic fields acting on the atoms, which in turn can skew the time measurement, Barrett said. So, the cesium clocks are still much more reliable in their implementation than the new optical clocks, Barrett told Live Science.